because we need to use it in calculus. In calculus, we have some figure that is much better working in calculus. Operation with the calculus. Operation with the calculus is integration. It's a specific operation in calculus. Okay, one specific figure is most convenient using polar. It's easier. It's magically. When you solve in rectangular, the classical XY, it's crazy. You spend a lot of time and sometimes it's impossible. However, in polar, no, it's 1, 2, 3, doing too fast. So now this open the door. So the new thing you see now with me, different figure, interesting figure, like a heart and flower. Do you see the PowerPoint? I send the PowerPoint, no?
Yeah.
Yeah, but no, don't see now. I want to explain step by step. And don't worry too much for the graph, because in Desmos we're solving any problem. I want to show you how. The most important is understand the idea behind polar. Okay, normally the habit that we have is you have a point, suppose P. And normally we assign this component and this component. This is rectangular coordinate system. And you associate this like x, y. Okay? It's okay? Now in polar is different. In polar, we define a pole, que es the origin, pole. And one axis, que es coincident with the x-axis, que es the polar axis. Well, some book assign also another axis here, but on some book no. Hello, Victor Villamizar. Ayulei, Victor Villamizar. Okay, in which this axis is called no y, it's called theta equal pi over 2. Pero it's okay. Some book no. Now the important thing in the polar is can you do the segment connecting the pole and the point. And this segment is called R. And this angle, que is measured from the x-axis, que is the polar axis, theta. And you assign this like R, theta. So this is the new. Okay, sorry, I was trying to connecting. Okay, my NDC Wi-Fi. This is the problem of the online, guys. I suppose can default turn no more online class. Everything in person in the campus. I suppose, I don't know. Because in new cepa of the coronavirus, no, it's crazy. We never finished that. Okay, entonces this is the idea. The idea is now the habit is doing in the black R, XY. Now the new one is the red part R, theta. Okay, entonces what is the conversion? What is the equation que connecting x, y and R, theta? This is the thing you want to study now. And so you will be able to plot any point using both ways. And after we are doing several points to get a curve in polar. Okay? But the question is, look, I applied trigonometric. Professor Jasmine Valdez, sorry, I am a little late. A little. 5 minutes late. The equation is using trigonometry, x is equal R cosine theta. Because cosine is the ratio between adjacent, this guy is adjacent, and the R is the hypotenuse, and y is equal R sine theta. Sine theta. Because sine is the ratio between the opposite, y, x is the adjacent, over R. And this is the equation that allow me convert from polar to rectangular. Or Cartesian, it's the same idea. So when you have in your hand theta and r, and you want to go to the xy, you're using this equation. I plug it in, bam, 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 that's it. When you want to go in opposite direction, well, the equation is different. I have in my hand x and y. I need to find r and theta. Well, it's easy because r is square root x squared plus y squared. It's a Pythagoras, no? And theta is tangent inverse of y over x. Remember, tangent, by definition, tangent angle is opposite over adjacent. This is the opposite. This is adjacent, no? And theta is because I want theta alone, no? Theta is the parameter in polar, no? Is you divide y divided by x and find the tangent inverse and you get theta in degree or in radian, either way. And this is the set of the equation that allows conversion in opposite directions. So the information that I have in my hand is Cartesians or rectangular, and I need to convert to polar. This idea is clear?
No, Professor.
Answer me. No, but repeat at the beginning. Hello. A specific question. Come on.
I said, Professor, I didn't understand how we're going to convert.
Do you want to see an example? Is more clear?
Yeah, Professor. The example is going to be clear.
Example 1. Suppose I give you in polar 6, pi over 6. Okay, entonces, this information is given in polar coordinate. So I interpreted that this guy is r and this guy is theta. I need to convert to rectangular. A rectangle is x, y, correct?
Yes.
At the same point, in the same position, but two different ways to express the same idea. Entonces, using that equations. Look, that equations. That equation. Entonces, x is equal to 6 cosine pi over 6, and y is 6 sine pi over 6. Entonces pi over 6 cosine pi over 6. I remember que es radical 3 over 2, ¿no?
Yes.
Therefore, reduces 3 radical 3. And also sine pi over 6 1/2 is 3. My famous point is 3 radical 3, que es x value, comma y, que es 3. End of story. More clear?
Yes, now it's clear. Thank you, Professor. I understood now. Can I take a picture?
Yes, of course.
Okay, thank you, Prof.
Let's do one more in the same direction. Example 2. You have -4, negative pi over 4. In this case, I complicate your life a little bit because r is negative and theta is negative. When the r is negative, suppose to understand that point, suppose que es 4, pi over 4, positive. In the polar plane, okay, something like that, you select radio 4. 1, 2, 3, 4. It's in the 4 ring. And pi over 4 is here. Zoom. This is a point. The point 4, pi over 4. Because this is the angle, look, pi over 4. And this is the radio, que es 4. Así es negative, and that's different. Because negative pi over 4 is in the opposite direction. No es counterclockwise, no, es clockwise. This angle is negative pi over 4, and negative radio is in opposite direction. Okay, my recommendation to plot any point in polar is do first theta. You move it in the direction of theta. Theta equal negative pi over 4. And after, si es positive radio, stay the same. But si es negative, it's in the opposite direction. At that point, is located here, approximately. So this is equivalent, guys, like of, it's equivalent to say that point is in polar also is positive 4, 3 pi over 4. Okay, que es 135 degrees in this direction. So this and this is the same. So in polar it's a little bit ambiguous because you have different way to express the point. So using radio positive and theta positive, and using radio negative and theta negative, and their combination. Okay, the combination is radio positive, theta negative, radio negative, and theta positive. So no, there are no unique way. Like in rectangular, you see 3,4, x, y. Oh, it's unique possibility. In polar, no. In polar, depende, you know, because it's angle, yeah, angle, we have coterminal angle. But okay, don't worry for this. This is blah, blah, blah. The important information in this problem is not this, not this, and not this. This is extra, complementary explanation. The idea is convert this given point in rectangle. Okay. Entonces the formulas is, I want to recopy the formula, is x equal r cosine and y is equal r sine. Okay, let's do it. Entonces x is equal negative 4 because radio is negative. This is the idea que look like weird. Radio negative. Because it's another concept of the radio. No, normally radio you associate in circle que radio is distant and distant never is negative. But this is different. This is polar. In polar R, que no necessarily is radio. I call radio because I don't know, I lie. But actually it's the distance from the pole to any point. It would be positive or negative. Dependency when it's given. I try to avoid negative. But however, in the problem is given negative, okay, and you say I have to work with the negative, no? Cosine negative pi over 4. You know, cosine is even function, so now it's negative 4. Cosine pi over 4, using the property even odd. I know cosine is even, it's nice, so this negative disappear. And cosine pi over 4 is radical 2 over 2, so negative 4 radical 2 over 2. Simplify a little bit, it's negative 2 radical 2. Okay, I like that. And y, similar. A negative 4 sine. The same angle, pi over 4. Oh, this is different because sine is odd function. Entonces it's negative outside and negative together is positive. Sine pi over 4. Okay. Entonces, bueno, 4 times radical 2 over 2 is 2 radical 2. And the point is the famous point, minus 2 comma, minus 2 radical 2, sorry, comma 2 radical 2. This is good idea because I predict. Remember I predict, I predict que es in the second quadrant. I predict, right? Remember, do it again, bipolar, and actually is negative 2 radical 2 and positive radical 2 over 2. Our point in rectangular xy is located here. And polar was negative pi over 4, que is in that direction. Negative pi over 4. And also 4 in the other unit is exactly here. Because it's negative radio. Make sense? Make sense or no? Make sense or no? Confusing? Clear? Answer me.
It's clear, Professor.
No big deal. Let's move on to Bauer. So now,
Professor, I have a question.
huh?
Can we, like, we can convert the polar to rectangular. Can we do the opposite? Can we convert the rectangular to polar as well?
It's exactly the same I'm doing now.
Okay.
Now, Noela say conversion in opposite direction. Example 3, opposite direction. Suppose gets given 2, negative 2. It's given. And this is rectangular. See, a rectangular coordinate, this is X and this is Y. I need to convert to polar. And polar, remember, I need to find R and theta. And the formula is easy. The formula is R is equal to square root X squared plus Y squared. And theta is tangent inverse of Y over X. Okay, it's a square root 2 squared plus 2 squared plus negative 2 squared plus negative 2 squared. Entonces 4 plus 4 es A, square root A es 2 radical 2. Because A is, 4 and 2. And square root A is square root 4, que es 2 radical 2. Okay, super. Now what's going on in the angle? The angle is theta is equal to tangent inverse of negative 2 divided by positive 2. Entonces tangent inverse negative 1. Okay, I have no idea with tangent inverse negative 1, but I know very well que tangent inverse of 1 is pi over 4. Yes or no? Because tangent pi over 4 es 1. Entonces I suppose que my angle lie, because it's negative tangent, lie in the fourth quadrant or in the second quadrant, no? In the fourth quadrant or in the, okay, tangent is positive, here is positive, or positive here. Maybe here or here, in the second quadrant. In the second quadrant, es obvio que es 3 pi over 4. Y in the fourth quadrant, well, in the fourth quadrant, you can represent like a negative pi over 4 using negative, or si you prefer positive, by the way, its equivalent solution is 7 pi over 4. So I need to recall quickly que this is pi over 4, this is 3 pi over 4, this is 5 pi over 4, and this is 7 pi over 4, no? So my angle lie in the second quadrant is this guy. Oh, and the fourth quadrant is this guy. This is the supposition que es the angle is measured counterclockwise. However, if you measure clockwise, it's negative pi over 4, que es equivalent to this. Okay, entonces what solution I put, Professor? Why don't you put either way, because they are equivalent, no? Entonces the R is 2 radical 2. This is R. And theta is either way 3 pi over 4 or 7 pi over 4 or negative pi over 4, either way. Remember, we have 4 combinations, no? Using positive radio or positive angle or negative radio and negative angle. But no. I prefer positive. No, hello. I prefer positive. Well, it's up to you, no? Shh. I prefer positive. Do you follow me? This example 3?
Yes.
Okay.
But Professor, if we put like one of those solutions,
it's correct. It's correct. It's equivalent. 100%. Example 4. Example 4 is another polar, another rectangular, sorry, que es negative 1, negative radical 3. So this is X and this is Y. I need to change to polar. R theta. Okay, I'm using the famous formula, square roots, X squared plus Y squared, and theta is tangent inverse of y over x. Okay, you keep in mind this formula, no? Or copy one piece of paper. Remember, I don't like memorize any formula because you memorize and you forgot. So you see in the cheat sheet. So specifically, is -1 squared plus negative radical 3 squared. Bueno, -1 squared is 1, and negative radical 3 is 3, and 3 plus 1 is 4, and square root 4 is 2. This is the radius. So radius 2. 2 comma something. 2,1 angle. In degree or radian, guys, I don't know why I put always pi, radian. And you like expressing degree, it's equivalent. It's another possibility. But okay, no problem. Tangent inverse of negative y is negative radical 3 and x is -1. Uy, entonces negative divided by negative is positive. Tangent inverse radical 3. So I don't know if you remember or no, okay, the angle that satisfies this condition is 60 degrees or pi over 3, no? In the first quadrant, of course. So the tangent is positive, in this case positive, yeah. In the first quadrant and the third quadrant. However, my point lies in the third quadrant because it's -1, negative radical 3, so negative x component and negative y component. My point is here. And this radio, okay, I get is 2. And this angle, okay, I get actually is not 60, it's 240, right? Because 60 is the reference angle, 60. So I know, okay, tangent 60 degree, radical 3. Do you remember this or no?
Yes.
So you don't remember, no problema, because I suppose you remember in this moment que sine 60 is radical 3 over 2, no? And cosine 60 is 1/2, no? When you divide this guy, tangent, no? The radical 3 over 2 times 2 over 1, que es radical 3. Entonces now I discover that we have two possibilities, no? In the first quadrant, que es 60 degrees, and in the third quadrant, que es 240. How do you know get 240? Because of 180 plus 60, 240. 240 expressed in radian is 4 pi over 3. Either way, guys, degree or radian is equivalent, no? This is the beauty. You make a complaint, you have several possibilities. It's better. You have several possibilities. You have more degree of freedom to manipulate that. So now, what is the final answer? Well, my final answer is the polar is 2, and the angle is 240. The student can prefer degree. Another student can no prefer degree. Radian is 4 pi over 3 in the story. Any question?
I have a question, Professor.
Go ahead.
Can we use the tangent inverse in our calculator?
Yes, absolutely.
Yeah, rather than just, for example, when
come on, try. You put in your calculator radical 3.
Okay, I'll try it now.
I do that. You put a radical 3, square root 3. Okay, by the way, square root 3 is 1.73 something, no? I know my memory because this number is very frequently used in engineering. It's radical 3, 1.73. And now, Nuela, you press tangent inverse, que es in the same key of tangent, but when you press second key, then you press second tangent inverse of what? Of the answer. And the answer is the same key in my calculator at least, que es the negative y color key. So you press second, this, que es answer, close the parenthesis, press enter, boom, 60 degrees. Do you see?
I'm doing now, Professor, but I don't.
Okay, look, the sequence of key is, I put in the calculator radical 3. I get 1.73 something. One more digit. We say rational number. Now you press second, and you press tangent key. So in the display, you see something like that. Tangent inverse. Make sense?
Yes, it does.
Now, you press answer. And what means answer? Answer means the previous number. An answer in my calculator is located in the same key of the negative value, no negative subtraction, no negative value on white color. You press second that key and you see answer, and you press equal and you get 60. If your calculator is setting in degree. Super confusing or super clear?
No, that was clear. That was clear.
Okay, after you go to the tutoring, yeah, explain details, okay?
Okay, I will. Thank you.
Okay, so now we know very well how you plot the point in the polar, and how we convert polar to rectangular or rectangular to polar using the famous equation. Okay, no problem. Now let's see now a curve, the transformation for the curve. For example, let me start with the elementary example. Suppose example 1, curve in polar. Okay. Suppose R equal example 1. R equal 3. R equal 3. What is the representation of R equal 3 in polar? Now, normally the function f of x equal y in rectangular, no? In polar, well, in polar is R is considered. So in rectangular, x is the independent variable and y is dependent variable. In polar, no. In polar, R is the dependent and theta is independent. This is the idea. Well, suppose que es given this idea. R equal 3. So R equal 3 weird because do not depending of theta. Theta is missing in this equation. No? Okay, but no problem. It's similar to the thing you know. In rectangular, suppose rectangular. Let me create analogy to understand. Suppose xy. Suppose the equation x equal 3, que not depending of y. Oh, it's a vertical line passing to 3. Yes or no? X equal, easy. And y equal 4. Oh, it's a horizontal line passing to 4, right? Because another variable is missing in the equation. Entonces, en polar no. En polar is different. Let me show you. In polar is the polar paper que provide in the paper or in Desmos. You don't worry for this. Is, you know, something like that. Different angle. One. And different circle. This is a typical polar paper. Entonces, R equal 3. Oh, theta is missing. Do not depend on theta. Therefore, it's obvious que this represents a circle with a radius 3. Totally independent of theta. Okay, unbelievable, but it's true. This is a circle. Equation in polar. Let me prove. Do you understand this or no? Okay. Polar have different concentric, so the same center, co-center circle. Okay, the first one is 1, the second is 2, 3, 4, 5, 6, 7. Now you say R equal 3 is the circle with the radius 3. End the story. And what happened with the theta? No, the theta do not appears in the equation. Therefore, it's independent of theta. Any theta. Just in case, I want to show you. I know very well this equation. R in polar is square root x squared plus y squared. So you replace, suppose I want to convert. Now no point equation from polar to rectangular because I am familiar with the rectangular. I'm not familiar with the polar. Entonces es replace, no R anymore. I put square root x squared plus y squared equal 3. And you square both sides because I want to eliminate the square root. And the equation is x squared plus y squared equal 9. Got it. And this is the very, very familiar equation for the circle whose center is located at the point 0,0, the origin, the pole in that case, and the radius is square root this guy, the 3. Boom. Do you see that?
Yes, Professor.